Welcome back. This is episode number 7, and today we are talking about Into the Metaverse. So, let's open up, see what we got. We extracted the DRM module from a target device, but haven't been able to reverse engineer its validation logic. See what you can do. And then we get a binary orig metaverse. There it is. Alright, let's open it up in Ghidra and see what we're looking at. Okay, looks like we're all loaded up. Now let's go to the entry. Looks like we aren't given our main symbol like normal, so we're gonna have to do a little bit of like on the fly figuring out what's going on. Looks like we put this virtual reality string. That's nice. Okay, and then we print something. Stir C-spin. Let's see what that is. Oh, okay. So you can give it a reject string and it goes through the string until it gets to one of the reject characters and then tells you what offset that happened at. So probably, if I had to guess, going through trying to figure out the new line character, this is 0A is a new line. Okay, so it's trying to find the new line, and then let's see what else here. Okay, and then some ridiculous number of conditionals on EAX. Okay. So this is probably a good problem for angr, which is good. So let's try to fire that up. So again, we'll copy our solve script. I guess 5 solve, copy it here, and then open it up. Nice. And we'll just get rid of some of this. And this will be Metaverse. And now let's open up our Docker container. Open up the project. Okay, and now we are ready to go. So let's say, let's give ourselves a new simulation manager, p.factory.simgr. Let's let it whirl. So while this is doing something, we're going to take a look at the error messages just like we did in, I think that was episode number 4, where we learned about veritesting. And instead of what was happening there, where we were having ridiculous numbers of states, instead what we have is like a small number of states, simulation manager with 4 active states. But they're taking a ridiculously long time. Look at how long it takes angr to emulate this 7BB2 D3 block. And it happens a lot. I mean, it's not always exactly that address, but it's like close. So it's probably like in the same function or something. So let's take a look at what's at this place. Oh, I don't know. This might be in like some loaded space, which seems pretty likely actually, to some library function. How can I see what's there? I think what I can do actually is I can say p.loader.what it's like, okay, so I see it says find section containing. Oops. And then this takes an address, so say this bad boy. So it's in the text address spaces. So another strategy here is we'll say sm.active. Oh, okay. We also have an errored one. That's interesting. We'll say sm.active of 0 to play around with. To play around with, we'll say sm.active is 0. And we'll say, so this address is here, but you can say s.history to get a list of where it's been. We'll say .bbl adders, which is like a iterator of all the addresses where it's been before. But we want to see it in hex, so we'll say list map hex onto this bad boy. Okay, so now we can see all kinds of stuff about where it's been. In this area is where it was getting stuck, so let's see where it was right before that happened. Looks like this address. We'll go to Ghidra, we'll say find. You'd think I'd know the key by now. And then we have to rebase it at the correct spot. Okay, so there we are. Stir C-spin. So it's spending a bunch of time in there. Probably because in the user input, each data could be a new line. So the symbolic execution engine is like, well, you know, this one could have been a new line. Well, this one could have been a new line, and so on. And so we don't want that. So instead, I think what I'm going to do is I'm going to teach you how to use the hook functionality of angr, where you can overwrite instructions. What we're going to do is we're going to go back to that main function, wherever the heck that was. Yeah, here. And we're going to overwrite these 5 bytes to do nothing. We're going to be like, yeah, just don't call stir cspin or whatever. Because all it's doing is it's saying like how long until you got to the new line, and then it's moving a 0 pointer there. So it's like, whatever. We could probably make all of this a NOP, which maybe, I don't know, seems like it may be okay. The problem might be side effects, like RDX might get filled with something and then use, and I don't know. So instead we'll make a really minimal change. We'll just replace this, and then we'll make RAX like some large value where it's going to end up writing that null byte. So, okay, here we go. So we'll copy that bad boy, and we'll say offset to hook. Is that? Maybe we'll call it like an address, like a normal person. Okay, so we will just now make the function that we want to overwrite those bytes with. So we'll say def op, and it takes a state object. And inside this state, we'll say state.regs.rax equals 36. And I don't actually know how many bytes we want to write before the new line, but it has to be enough to fit the flag. So I'm just taking a wild guess here. We'll see what happens. Okay, and then we have to register it. So we have to say p.hook, and I just have the documentation open on the other monitor here. Adder equals adder to hook equals nop, and length, this is how many bytes to overwrite. You could put 0 if you wanted to. So now that that's all set up, we're going to make our simulation manager. Let's p.factory.simgr. Okay, great. And so now we should be able to close out of this, and we should be able to start another run. Okay, so we should be able to say sm dot. Great. And so as opposed to last time where each step was really, really slow, we're actually getting somewhere. So I see 2 new avenues for us to sort of improve this and make it even better. The first one is we can specify a goal. We can tell it where to go. And sort of off camera there, I just sort of clicked through each of these functions. I didn't do anything complex, but then I found this function, flag captured. So I think that that's a good goal place for us. So we'll say sm.explore find equals this with the correct base. Oops. And then we'll say avoid the one that said wrong. So that way, just we don't spend any extra time down that path. That's not necessary. Okay, so then there's that, and then there's another step that I see we can improve. Each one of these tick states has one satisfiable condition and one unsatisfiable condition, which basically means we're just following a single path through the program, which, like, angr can emulate programs, but it can't emulate programs quickly, and but Angr gives us a nice wraparound an emulator that can do things quickly called Unicorn. And so we're going to take advantage of that. So the next thing we'll do is we'll make an entry state, s equals p.factory.entry state. And we'll pass it the Unicorn options, which there's a nice table in the documentation that is a great reference. So I strongly recommend you look at that. So we'll say add options equals angr.options.unicorn. Alright, we'll pass that state to the simulation manager, and it actually looked like the non-unicorn instance found our flag, potentially. So let's just take a look at that. For s in sm.deadended, we want to print p or s dot POSIX dot standard in. Okay, so let's see. All right, so it looks like that second state there actually found the flag. But since we already have it up, let's finish our little script and see how Unicorn does when compared in this particular instance. So we'll say if sm.found s equals sm.found of 0, print s.posix.standard in. Okay, so now let's try it with Unicorn. I haven't sped up the video or anything, but you can see the text is flashing much faster than it normally does as a result of the Unicorn engine spewing out a bunch of new text. Potentially we could speed this up even more by turning off the logging so that we're not throttling on how frequently we can print to the screen. And there it is, there's our flag, much faster than the previous time. So I think that will do it for episode 7, and I will see you next time.